Integration of acid bases in electrolyte source. Introduction. This review describes a method of analyzing acid-base disorders that incorporates insight from the traditional bicarbonate-centered model and the Stewart model, or strong unit. Acid-base balance and electrolyte homeostasis are intricately connected at the cellular level in the clinical disorders. Acid-base balance. Acid-base balance and the video.
The body is very sensitive to its pH level, outside the range of pH that is compatible with life in many physiologic processes, such as the maintenance of energy stores and renal regulation. Respiratory regulation is considered as a physiologic type of buffer, which is 1 to 2 times as great as chemical buffers. Its pH from drifting far from normal. Approximately 60 to 70% of the total chemical buffering of the body fluids results from the action of intracellular proteins that have high concentrations and pKs fairly close to 7.4. In the red blood cell, hemoglobin is an important buffer. As for maintaining the normal pH in the plasma is renal excretion, which makes use of chemical systems. Now let us travel through the urinary.
Most acid-base abnormalities can be diagnosed and interpreted with the use of traditional approach. In this article are several cases vignettes that show the explanatory power of the strong ion approach in clinical practice. Conclusions. Clinical evidence can be interpreted with the use of both the strong ion theory and the traditional bicarbonate-centered approach to provide an optimal understanding of acid-base disorders. Electrolyte concentration of plasma may be altered by the gains and losses associated with intravenous fluids and with urinary, intestinal, or sweat glands secretion. An understanding of the consequence of this disturbance helps in the diagnosis and treatment of the associated acid-base disorders.
The following tutorial is on acid-base balance. Acid-base balance occurs constantly each and every day due to metabolism, generating hydrogen ions. 2 types of acid exist in the body, described as volatile and non-volatile. Non-volatile acids are generated from oxidation and metabolism of other molecules such as proteins. The volatile acid is considered to be carbon dioxide, as this rapidly reacts with water to form carbonic acid, which further dissociates into hydrogen and water. This can be seen in the equilibration reaction, where carbon dioxide and water form carbonic acid, which can form bicarbonate and hydrogen ions. This volatile acid is excreted from the lungs in the form of carbon dioxide, with at least 12,000 millimoles per day being exhaled. The kidneys, however, are responsible for the excretion of fixed non-volatile acids, and although comparatively there is only around 100 millimoles per day, this is a critical role. The normal pH is 7.4, and it is important for cellular function. Although life is capable of some variation, it is important that this is well regulated. A shift in pH can occur with either a change in bicarbonate concentration or carbon dioxide concentrations. Control of carbon dioxide concentration is by the lungs, while bicarbonate is controlled by the kidneys.